me, and we provide training services on in many different areas. I suppose what we're doing today, this sort of VoLTE thing, probably comes into, as we might call it, the School of Advanced Communication. So, technology type courses, in-depth engineering training, and so on. And also a lot of what we'll talk about today will be covered in things like the distance learning programs that we cover. But we've also got, as we call it here, the School of Telecoms Management, where we deal a lot more with the sort of the business and commercial issues related to telecom operation and such like. And some of the programs we do as well, you'll notice at the bottom here that we've got university accredited programs. So we've got a relationship with Derby University here in the UK. And by participating in some of the programs that we have, the mini MBA and some of the distance learning programs, you can actually qualify for some university credits at the end of the program. I'm going to put the last slide I'll show you today is there'll be a bunch of links to our websites, email addresses, contact details, and so on if you're interested in anything that we do, as well as I mean, since you're here today participating in the VoLTE webinar, we've got a couple of VoLTE training programs coming up very soon as well. So we'll put the schedule for those up right at the end as well. You can have a look at those while we do the Q&A towards the end. Now, Telecoms Cabinet is part of a much bigger organisation, Informa Telecoms and Media. Partnered with Ovum Research, and one of the great advantages really working for a training company that also has access to all of the Ovum back catalogue of reports and so on, and the tools that they have. So what we'll be presenting towards the end of this report today, or the end of this session today, will be some information from the latest VoLTE report that the Ovum analysts have put together. So hopefully you'll find some of that information interesting. Now, well, let's jump straight into it. And talk a little bit about the business of voice. We're very used to these days thinking about the smartphone and what we do with the smartphone, and it's a lot about the applications and so on that we run on these devices. But from an operator perspective, whilst we have to provide the data connection, the services that allow connections to the internet and such like, still quite a large percentage of the operator's revenues is coming from the traditional classical sort of voice SMS. So an estimated market value here of sort of $600 billion. I mean, that's obviously a global figure in there, but it's not without its challenges. There is still demand, of course, for voice and messaging. I mean, that's still what we want to do primarily, I guess, with our phone, the communication devices. But maybe the way in which we're using voice and messaging services is, of course, changing. So the traditional voice, the traditional text messages, the SMS supported by the operators, there's lots and lots of options out there for us to communicate in alternative ways, and it's the usual examples of WhatsApp and Skype and so on that perhaps taking away revenues from the operator's core business. So VoLTE kind of sits in this space where we can offer sort of OTT-like services, but directly hosted, directly provided by the operator's network. Now, smartphones. Well, yeah, we like smartphones, and in many countries in the world, smartphone penetration is very, very high. 70–80%, perhaps more in some countries. But there's this sort of combination of the smartphone device with an internet connection. To a large extent, what that's doing is enabling the so-called OTT, the over-the-top players, perhaps to leverage their services, making use of the sort of high-quality internet, fast internet, low-delay connections that are being offered by the operators. So, of course, in this this gap, this window, where we're trying to move away from the traditional voice services towards voice over IP services and alternative instant messaging, there is a sort of period of time here. There's a window where the OTTs are currently perhaps winning, we would say, in that voice over IP instant messaging space, and VoLTE is there to kind of fill that gap and allow the operators perhaps to compete on a more level playing field with those operators, and offer very similar kind of services that we're used to these days with both with the desktop clients like WhatsApp is on the desktop these days, or at least within your browser, and Skype and so on. And when we think about our the usage experience that we have with a lot of these OTT applications, it's being able to see not just your telephone directory, but also you get kind of presence information, location information. People will change the status They can indicate that they're in a building or they're on holiday and so on. And that's something perhaps that's lacking in the embedded telephony function of the smartphones at the moment. But VoLTE and its applications will bring that kind of functionality directly into the smartphone. And it will be an embedded part of the device as well. There'll be no need to download another application to sign up and register for different services. It will be seen as really just part of what the operator can deliver. So that might give the operators a bit of an edge. I think I put in my in one of the sort of the comments in the chat pod there, I put in there that in the long term, well, medium term to long term, I think this will probably give the operators a little bit of an edge, because it just becomes the de facto thing. It's going to be the way in which the smartphones operate in the future. And it doesn't necessarily have to be a smartphone, because in the end, what is a smartphone today? It's a computer with a fancy screen running a bunch of applications. We're very used to this kind of idea. Perhaps they're still a bit on the expensive side. When we're trying to reach out to the emerging markets, smartphones perhaps are still a little bit on the pricey side. But a simpler phone these days, even as we might call them, like a feature phone, I suppose we used to call them, are still computing platforms, and VoLTE, if we see VoLTE just as an application that can run in that environment, we don't necessarily need a complicated, expensive smartphone to run these kind of services. So in the evolution of the networks, of course, we started a long time ago now. I mean, GSM now is what, 23, 24 years old, I think. And of course, it was designed originally on the back of a voice-based network. So it was, there was the core network was based on an ISDN architecture. A lot of the signaling, a lot of the protocols and so on were used based on that ISDN protocol. And of course, the support for the voice really came from the core network. We had our big telephone exchanges sitting in the core network. Well, I suppose by today's standards, a relatively sort of simple interaction, a simple interface between the user equipment, the access network, and the core. The one thing that the 2G network kind of lacked, of course, was any real data connectivity. I mean, that came a little bit later with GPRS, and for simplicity reasons, I've omitted GPRS from this particular picture. But sort of, mid-1990s towards 2000, one of the things that we were demanding was then access to the internet on our mobile phones. So of course, along came 3G, completely different access network, slightly fancier radio interface here, supporting higher data rates. Still in support though of the voice services, but this idea of internet connectivity on our devices, data applications and so on, I mean, that's enabled not just by the higher speed radio interface connection that we have, but of course by connections to a data core, which is giving us access to, well, I suppose we could just put here the internet, because after a very short period of time, of using these devices, of course, we all demanded direct access to the internet. Initially via GPRS, then of course with a slightly better 3G service, and then things really took off in terms of data services when the high-speed services like high-speed packet access, HSPA, HSPA Plus came along, and now we've got sort of, well, okay, the theoretical numbers, I suppose, for HSPA Plus, we're looking at what, 21 megabits per second. That's sort of the theoretical data rate, but even 5-10 megabits per second is a reasonable data rate for us to perhaps stream movies and so on. And even beginning to enable the real-time services that we might require, such as voice over IP or FaceTime, voice and video over IP networks. These services now, perhaps driven by the OTTs again, those guys sitting out there on the internet, is enabled by the higher speed connections that we have in the access domain. Now, because of all the applications that we're using our devices, and because of the demand we place on the network, clearly more capacity has to be a feature of the network. And we've gone pretty far with HSPA Plus. We've got those fast and efficient modulation coding schemes. We've got so-called dual carrier HSPA, some clever antenna techniques, and so on, pushing the data rate up all the time. Now, even though HSPA is a sort of 3G technology, continues to evolve and improve. We're very used to these days. The whole idea of, well, as we now call it, 4G LTE, where we've got data rates now, a very fancy new radio interface here is giving us data rates, in the order of sort of 100 megabit per second or so, depending on, well, your mileage may vary to a certain extent here, depending on how the operator is configured. Depending on what kind of device you've got, all those kind of things. But 100 megabit per second is normally the number we would throw at that. So yet again, this is an enabler for the cleverer, more real-time services that we have to have in the system. Now, clearly, this network, now the access domain that we have here is the one that's providing us with the high-speed services, but of equal importance really is what goes on in the core network. Something that we'll start to talk about very soon here is the need for quality of service, and I think in one of the polls here asked what one of the sort of the qualifying success factors of LTE would be, and I think maybe the number one answer there was related to quality of service. Maybe when we look at the 3G network, HSPA network, whilst we have the idea of quality of service, perhaps it's not been fully engineered into the network in a end-to-end fashion, and perhaps we're very used to this idea now of best effort sort of internet services, which really means during the peak hour, if everybody's connected to the system at the same time, we're all going to experience some kind of slowdown. Now, if you're running an OTT voice over IP application like Skype or Viber, then during the busy hour, your internet connection is going to suffer as much as everybody else's, so people's video will start stopping and stuttering, and your voice over IP application will do the same thing. So if we're going to offer a voice service via a data network like LTE, then of course it's absolutely crucial that we have throughout the network some support of quality of service, end-to-end quality of service. Now, end-to-end in this case, well, it depends where the ends are, I suppose. But if we call this UE here the A party, and this is the B party, still connected to the same network, then via the evolved packet core that we have here, this data connection, then the connection from A to B, we could describe this as an end-to-end connection. But of equal importance, not just the media connection, obviously that's an important thing because we want the voice call quality to be good and so on. We don't want there to be any excessive delays in there. But of equal importance, if perhaps more important, would be the signaling associated with the establishment of the data sessions, which we then run the media through. Now, this is where the IMS kind of comes into play here, because it is now, should we say, the mandatory technique that will be used to support the VoLTE service. Now, IMS is it's an old it's an old idea, I suppose. It's been around for what, 10-15 years or so. Perhaps we didn't make a huge success out of it when it first came along. Yeah, I think just because we weren't ready for it. The telephones weren't available. As subscribers, perhaps we weren't as educated as we are today about the services and applications that we could run on our devices. But the IMS has kind of got a bit of a second life now, in that it's an ideal platform, particularly the control mechanism that we use. There's a technique here called SIP. I'll say a bit more about that shortly. But this session initiation protocol is designed to work over the back of an IP network. And we have exactly in LTE, we have an IP network all the way out to the mobile device. But any exchange of signaling to set up the call, to modify the call, to add components to the call like video and such like, all of these things must be signaled in real time. So very, very low delay connections out to the IMS. And again, this is where quality of service becomes a crucial factor of the connection. So all the pieces are in place to an extent, in that we've got an IMS platform, we've got SIP capable servers and so on sitting in the IMS. We've got a fast and reliable network that supports quality of service. Our access domain as well has got now high capacity, and increasingly there are mobile devices in the market that can support these advanced kind of services. Yet for VoLTE to be a success, there are still a lot of factors that all have to line up all at once for us to be able to launch a successful VoLTE service. And we'll deal with a few of these issues as we go through this presentation. Now we can probably just take a step back for a moment and say, right, okay, we have an LTE network, and here we have this sort of central component here, of course, is the EPC, as we would call it, the Evolved Packet Core. And we've got the typical functions of the MME, the serving gateway, the packet gateway in here, where the MME is really sort of a signaling plane, shall we say, and the P gateway and the S gateway here are, let's call it the user plane. So all of our user data will pass through these devices to and from the mobile. The mobile devices, and the MME is just there in charge of the bearer setup and so on. Now, I'm not going to worry too much about the technicalities of the LTE network and so on. We'll maybe focus more on the end-to-end processes. So that means we can sort of take a step back from the network and say, right, okay, the LTE network then, all of the components of the LTE network, including the base station, the radio interface and so on, it's a delivery system. Okay, so the first bullet point we have here says LTE network is a transport/delivery network. And in particular, it's a very good delivery system for IP packets. Maybe one of the, well, certainly one of the initial concerns of, when we first started looking at the LTE network, maybe 5 or 6 years ago, was that at that time there was no properly defined end-to-end mechanism in support of voice calls. Now, if you go back 5 or 6 years, then, what, 18–90% of the operators' revenues are still coming out of the voice and text messaging services. So this apparently new technology, which is somehow meant to replace our existing 2G, 3G network, it's a matter of concern then that there is no provision for voice services. Now this may have been done slightly deliberately by 3GPP, who are the standards bodies associated with LTE. And there was a little bit of a sort of a market battle, shall we say, to see which would be the prevailing technology in how do we do voice over an IP network like VoLTE. LTE, and there was a couple of ideas knocked around. Some of you, I'm sure, will remember a service called VOLGA, which is voice over LTE using sort of generic access controllers and so on. Well, that's gone now. We can pretty much forget about that. So VoLTE, as we call it, the voice over LTE standard, is the one which is now mandated into the 3GPP specifications, and also we can, I don't think I've referenced any of these documents actually, but perhaps I should, but the GSMA is a great place to go and look to find out more, well, should we say, general information and some good technical documentation about what VoLTE is, really led by the GSM Association. Now, if you like reading technical specifications, and I'm sure many of you do, the document that you need to start with is a document called IR92, okay, which is a sort of a service description of voice over LTE. But one of the good things about this document, if you want to do further reading in it, is that there's a couple of pages in there with a long list of 3GPP specifications and other GSMA documentation. I mean, it covers things like roaming and billing and other kind of complicated scenarios that we need to get a grip with if VoLTE is to be a long-term success. So the LTE component of the network, so the P gateway, the serving gateway, the access network, and so on, is just a delivery system. Okay, so it pushes IP packets backwards and forwards according to some quality of service rule. But to make the network do something that could be described as an actual service, we need a back-end system which will provide us with the call setup capability, the call manipulation and modification capability. So these kind of big components, these meant to be sort of service, I suppose, sitting in the back end here. This is where the services will be rendered. So of course VoLTE is the one that we're concerned with today, but I mean those servers could be anything. I mean, they could be video streaming servers. They could be push-to-talk servers for public safety. They could be pretty much anything. But this is why the QoS is so important, because whatever you put at the back end of the network here, all of the different services that you could possibly list will have differing requirements when it comes to delivery. So quality of service is, crucially important really to the success of a service like VoLTE. These servers that sit at the back end of the network, I mean, this could be something that the operator themselves would do. So they engage a video content company, they cache the content, they have a control system, a billing system associated with that. And all of that would be sort of a proprietary thing. It's not mandated by any standard how you would perform video streaming and so on. Delivering sports coverage to your customers and so on. However, VoLTE absolutely mandates then that we put these servers inside of a cloud, and we call that cloud IMS. And these components have got very specific names like call session control functions and telephony application servers and so on. So there's a whole architecture mandated by 3GPP which make the VoLTE network as a complete system, and LTE sits right at the bottom of that, if you like, as the delivery system. So there's a lot of different components that really come together as part of this. But since we're kind of going on about quality of service, perhaps we should say one or two things about why quality of service is so important. Now, there is this idea of bearers within the LTE network. Now, the bearer is just, should we say, a logical description of a connection through the network. And there can be many different kinds of connections through the network. But for the VoLTE service to be useful, it's really important that we have what we refer to as the default bearer. Okay, now that default bearer there is, well, it's difficult to sort of overstate the importance of the default bearer in respect of VoLTE services, because as soon as you switch on your mobile device, your LTE mobile device, and it connects to the network, then the network will automatically allocate an IP address and will give you this initial or this default bearer. That then allows any client, so I've got like a VoLTE application now sitting on my phone, and that then gives the mobile device and its applications a path through which it can send the signaling to perform SIP registrations, to talk to the IMS cloud and say, this is me, this is who I am. This is my contact list. This is my current presence or current mobility status and such like. So that red line that you see being drawn through the network here is effectively a signaling interface that goes through the user plane of the network. Now, signaling in any network is the most important kind of traffic that will go through the system. So anything that appears in that so-called default bearer has to be treated by the base station, the links between the base stations and the network, and all of the components that IP packet passes through. That SIP signaling packet must be treated with the highest degree of priority, the most important packet in the network, and in order that we can do very fast call setups, we can do fast manipulations or modifications to the call and so on. So that red line we're going to see, and I'll show you an example of some SIP signaling in a moment or two, and I'll remind you about the default bearer and the red line on this picture. But there'll be a lot of messages passed backwards and forwards through that line, where we establish my address, my identity, and we also establish perhaps the address and the identity of the B party in the call, so the person that is being called. Then what we have to do is to connect the A party, the originating party of the call, to the B party with a media connection. And this media connection then will be established via what we refer to as the dedicated bearer. Okay, so we've got the default bearer, which was basically you get that for free as soon as you turn your mobile phone on, and it never goes away. So as long as the phone is connected to the network, that bearer is always present, which means that the mobile also has a persistent or permanent IP address, so it always knows where it is in terms of an IP network. When you go to make the call, though, the dedicated bearer becomes the media component. Now that blue line is established when you require it. There is an important quality of service component in this as well, because now which codec are we using? Is it a voice and video delay characteristics of this dedicated bearer, which will carry the media? And when we're done with the call, well, we can tear down the blue line, but the red line will remain in place, meaning that the application will remain connected to the IMS, so any incoming calls to the IMS can be routed to the mobile and such like. So it's really important that we always maintain this so-called always-on connection, just so that we've got a path for the SIP signaling between the mobile client and the IMS cloud, the call session control functions, the SIP servers, if you like, that sit up there in the IMS. Now there is a relationship between the IMS cloud and, should we say, the router in the network, because that P gateway, the little brown box that you see there, is essentially the router in the network. So there may have to be decisions made by the IMS about the destination. So where is the B party? The B party could in fact be sat, should we say, in the PSTN, so in like a normal telephone network, in which case we need to invoke sort of media gateway functions. Okay, and the IMS is in control of the media gateway function and will provide routing information to the P gateway about how do we access the media gateway and so on. So there's an entire complication, shall we say, sitting in the IMS, and how do we manage and route calls and so on associated with that. But the important sort of picture to get from this diagram is that there will be at least one bearer established by the LTE device all the time. Okay, it's a permanent thing, and that really is to enable the voice over LTE service, the SIP signaling. And the blue lines, the media bearers, they can be added and subtracted from the network as and when the calls are placed and when they're and when we terminate the calls. Okay, now I can see my little sort of control panel here. One or two of you are raising your hand, so I assume you have some questions. Now, just so we can get the flow going here, I'll take those questions right at the end if that's okay, and we'll drag that chat pod back in, and I'll try and answer a few of your questions. Yeah, just to keep going on about quality of service, the bearers that we establish in the network can be categorized or can be indexed via this table, and there is a value here, the QCI, which is the quality of service class index or identifier, which refers to this table. So that default bearer, the one that connects the client application on the mobile device to the IMS, will be established using a QCI 5. Now QCI 5 is just it's an abstract value that refers to this table, if you like, but then we can see the properties of that bearer in that it is non-guaranteed bit rate. non-guaranteed bit rate. It's just signaling. We don't need to sort of open up any dedicated paths for that necessarily. But it has priority 1 out of 9. Okay, that means, of course, it's the most important type of service that would run through the network. So your QCI 5 traffic will always jump the queue at a router or a switch. It always gets there first. And also, we've got a very tight delay budget here. So we're looking for a, should we say, a client to IMS delivery time of no more than 100 milliseconds. And if we can kind of maintain that 100 millisecond delay end to end through the network, we're talking about a very fast call setup for IMS or for VoLTE services, and also very reliable. Okay, 10 to the minus 6 packet loss rate, so 1 in a million packets through the network is allowed to be lost, and that implies very high reliability. So we'll use the QCI 5 bearer to do the signaling and to set up the call, and then the one that we refer to as the dedicated bearer, this will be QCI number 1, which in this case you can see has a GBR, a guaranteed bit rate, in which case we then have to specify what the bit rate is, and what the bit rate is will depend on the voice codec or the video codecs that we might be using for these bearers. It has a priority 2, so 2nd out of 9 in terms of priority. Also a very tight delay budget, because now we're talking about the audio path, and we don't like communicating on, or at least we don't like communicating on two-way links where the audio is delayed by more than about 250 milliseconds. It becomes an uncomfortable conversation. But the packet loss rate, well, it's pretty loose, to be honest, 10 to the minus 2. So 1 in 100 packets of voice media can go missing in the network or can be unreliable, and we don't really care about it. So it's more about delivery time than delivery reliability, up to a point. Clearly, if you're losing too many packets, the voice call quality will be terrible as well. So as far as VoLTE are concerned, QCI 5, QCI 1 from this table really the important factors, but any other dedicated bearer that can be established in the system will use any of the other numbers that you see here, so QCI 2. Maybe just as sort of a slightly enhanced example here, the QCI 1 you could say, okay, it says in the example service here, voice information. So if you were doing voice and video in your VoLTE call, then it's quite likely that you would have a QCI 1 dedicated bearer established in the network, and in addition to that, a second dedicated bearer with a value QCI 2. So on the diagram from the previous page, in a voice and video scenario, would actually have 2 of the blue lines connecting the A party to the B party, making it quite a complicated network. Now, as you would imagine, there's a ton of signaling to do here. Now, we don't have the time here to kind of go into this in any sort of depth, but I thought I'd just give you a very quick. This is what has to happen, and this is the order in which things generally happen for VoLTE services. Now, before you ever get to the VoLTE signaling, there has to be some radio connection signaling, first of all. So this RRC connection here simply allows the mobile phone to establish a connection with the base station. And once the connection with the base station is established, there's a whole bunch of other signaling that has to take place, where we perform a registration with the core network. Okay, now this is the registration with the LTE network, so I'm talking to the MME. We're going through this default bearer setup, and we're also finding out about whether this network or this part of the network supports VoLTE. So all of these are specifically kind of core network functions, and as yet we haven't signaled into the IMS. Just for clarity on this picture, I'm just drawing a circle around the final 2 components. This is the IMS. So the CSCF, which is a very pleasant acronym, is the call session control function, or if you prefer, it is a SIP server, and we have an application server which kind of renders the telephony services for us and such like. So up until this point in the signaling sequence, we haven't yet spoken to the IMS. All we've done is to open up a default bearer connection, find out where the VoLTE network or the IMS network is, and once those things are in place, then the client application, the VoLTE application running on the phone now, can then provide us with an IMS registration process and maybe some security user authentications and such like. Now, all of this is likely to happen automatically when you switch the phone on. Okay, so all of these things will be done when you switch the phone on, and then well, it's possible at that point that the phone then just drops back into an idle state, and then when you go to make the telephone call, we have to kind of re-establish the radio connection, and once the connection's in place, it's at this point where we can start exchanging kind of detailed SIP signaling information, and this will be the actual call setup which would be taking place. Once we've agreed that the call can take place, so we know where the A party is, we know where the B party is, we know what codecs we're going to use, we know what quality of service is required for the connection. At that point, we then kind of we revert back to the LTE core network, and the core network in this case takes over and will establish the dedicated bearer. Then, of course, once the dedicated bearer is in place, we then have the direct, mobile to mobile, if it's a mobile to mobile call, mobile to mobile media connection is in place. So the dedicated bearer is handling that. And at the end of the call, again, the client application will signal the IMS cloud saying we're done with the call, we've hung up the call, so we can release the IMS resources that are in use. And then there is a sort of second phase of release where we can then release the dedicated bearer. But just note that we're talking here about release of the dedicated bearer. The so-called default bearer is still in place. That never goes away. That's the permanent, the persistent bearer in the system. So if you want to see a more complicated picture, well, here is one. And notice, excuse me, in the components we have at the top of the page, we've got the UE, and then we're straight into the IMS. So everything in this little orange box here is basically the IMS. So it's a bit of a struggle to fit it in here, but little cloud in there, which is the LTE network. So once we've got that connection with the IMS cloud, honestly, we don't care what the LTE network is doing. We just know it's a delivery system for IP packets. Now, there's a great deal of flexibility in the IMS, because the IMS is not completely bound or tightly integrated to the LTE network. Okay, all the IMS wants to see is IP connectivity. So that little LTE cloud that I've drawn in here, you can replace that with pretty much anything you want. Replace it with the internet, replace it with a Wi-Fi cloud, replace it with something else in there. So IMS is kind of completely agnostic of what the delivery system is. So long as we can see the IP address of the client, the user equipment, and there is a quality of service driven connection network between the two, we can perform this sequence. And in this sequence, what we're doing is, it is, in this case, a mobile originating call. And the invite that you see here is a SIP message. SIP is very polite in that it invites the B party to participate in a call. And then we have inside of the gray box here, we've got really negotiation. So what we're doing is making sure that the other end is available, and that we agree on the codecs that we're going to use and such like. And the updating procedure here would take place once we've agreed on the codecs and that the dedicated bearer through both of the networks, because of course we have the originating network and there's also the sort of terminating network, which has to perform a sort of a similar sequence, perhaps in mirror. So if we just mirror this sequence, the same thing is also going on in the terminating system. Okay, then of course there will be some ringing of the phone, and at the exchange of the ACK message, which you see right at the bottom here, the acknowledgement, then the media component can be connected, and then you're in the telephone call. Now it looks like a very sort of chatty sequence here, but the call setup time is extremely low, which is of course is a good thing. So we're looking at sort of in the order of maybe hundreds of milliseconds, perhaps less than that, to do all of this signaling. So when you press the send button, the call button on your phone, by the time you kind of really lifted your finger off the button, the connection's in place. So it's very, very fast, which has to be a good thing. Now, of course, all of the preceding statements we've made pretty much rely on the fact that you have a voice over LTE enabled mobile device, okay, with the appropriate applications and so on embedded in the network, and also that the network, the LTE network itself, both has LTE radio coverage, which I suppose is a given, and that you have an IMS connected to the network, which is also in support of VoLTE. Now, I mean, these are obvious things to say. VoLTE is not going to work without, if one of those things is missing, then VoLTE doesn't work. But for many operators, I mean, VoLTE is going to be like a long-term deployment in many ways. Well, first of all, I can't make a VoLTE call if there's no LTE coverage. Again, another obvious statement to make. But it's going to take operators a very long time to make LTE coverage look as good as the 2G coverage. So LTE is really being deployed in the network as an overlay, if you like. So what we're doing is we're overlaying small islands of LTE in the bigger network, meaning that for quite some time, it's extremely probable, in fact, that the LTE coverage is a lot less than that of the 2G or perhaps even the 3G coverage. So there will be times, of course, when you go to place a call with your LTE device, and there is no LTE coverage, in which case the call that you make with your LTE phone is just a 2G, 3G phone call. I mean, that's it. But of course, there will be times when you have your 4G telephone and you are connected to the 4G network and you go to make a phone call. Okay, now in a network which doesn't yet support VoLTE or doesn't support VoLTE in this area, then we have to use this technique called CSFB or circuit switching fallback. Right now, I must admit I'm not really a fan of the term fallback here because it sounds like a random thing that's happening. I think a better name for this actually would be circuit switching redirection. Okay, because that much more accurately describes the actions that take place. So when we're performing the fallback process, so you dial the number, you press the send button on your phone, your mobile phone, whilst connected to the 4G network, will basically talk to the MME and say, somebody's trying to make a phone call. Okay, now in this network, of course, the MME and the base stations, the mobiles will perhaps know that VoLTE is not supported in this part of the network. So really, what the mobile phone is doing is asking permission to leave the LTE network. So what the MME will then do is provide permission to the mobile to leave this network. And where we have this information available, we will also inform the mobile of which 2G, 3G base station to fall back to. So this instruction from the LTE network to the mobile that includes a description of which base station or which radio access network to use is more of a redirection. Okay, so the MME is saying, okay, you can't make the call here. Okay, so why don't you try this base station? And at that point, the mobile can leave the network, and then we place the call as we always have done. So then it becomes purely and simply a circuit switching call. So like we've been doing for the last 15 or 20 years or so. So I mean, yeah, most operators are in a position where they're providing the fallback solution because I'll show you a chart in a moment or two, but there's not that many VoLTE networks live in the world at the moment. But there are many more 4G LTE mobile phones. So every time you make a phone call on your LTE device, it's probably going to be a circuit switching fallback type of situation. So it is the whole fallback. It is an interim solution, a temporary solution, until we have full LTE coverage with, everybody has VoLTE enabled mobile phones and, and so on. But that's a very long-term thing. We can't create 100% coverage just overnight. We're talking 3 years, 5 years, perhaps longer than that for some operators before we can just forget about circuit switching fallback. But it is nevertheless an important interim solution. To support this as well, I mean, that's sort of the basic procedure, should we say. Some modification needs to be made to the network. In that the MSC, the telephone switch, if you like, or the telephone switch server that sits in the network, needs to be connected to the MME via an interface called the SGS. And that allows us to provide for registration. So when I perform my registration with the LTE network, the MME can perform a circuit switching registration on behalf of the mobile. And it also allows the MSC server for mobile terminating events. Okay, so somebody phones you on your mobile phone. There's well, it's supposed to look like a telephone, but there you go. So this is a mobile terminating event, in which case the call is routed to the MSC server because, well, it's a telephone call. And the MSC server then is able to route the call setup information, or at least the initialization of that, towards the MME. And then what the MME will do is to perform basically paging. Okay, so we're going to page for the mobile. The mobile then responds to the page by talking to the MME, and it basically says, what do you want? And the MME says, you have been called, please redirect, and we end up on the 2G, 3G network where we accept the call, again in the identical fashion that we have done for the last sort of 10 or 20 years or so. So the SGS interface is an important element of a network that supports circuit switching fallback. There might be a couple of disadvantages to this, in that mobile terminating example, what you may be doing on your phone is you're connected to the internet and you're streaming a movie, you're watching YouTube or something, and it's coming in through the network. Now, when somebody phones you, because you are now being redirected to a non-LTE network, possibly even a 2G network, this means that the bearer, which is established in the LTE network, perhaps cannot be handed over, or it's not, there's not enough capacity in the destination network to support this connection as well. So this so-called, we used to call it DTM, dual transfer mode, or simultaneous voice and data, where we've got circuit switching fallback, the whole DTM thing kind of breaks down a little bit. I mean, there is a possibility that if we hand over from LTE, let's say, to an HSPA plus system, where there is sufficient capacity in the destination network, in the HSPA plus network, it may be possible to hand over the bearers from the LTE network to the UMTS network. But there would need to be some sort of careful analysis of the available capacity to take the video session as well as manage the call in that case. So DTM, okay, it needs some thought. Dual transfer mode needs some thought. Where you have VoLTE supported in the network, then naturally, of course, it will support a dual transfer mode, because the video bearer, okay, your YouTube video, if you like, will be established through a dedicated bearer through the network. And when the call comes in, all we do is we add a new dedicated bearer to the connection, which now contains the voice information. So you can continue to watch the movie whilst you make the phone call, or you can check your emails while you're talking to the boss on the phone as well. So the whole dual transfer thing is a sort of, it's an integral part of the LTE network when you have VoLTE supported by the system. Now, another complicated, and this is honestly, this is just insanely complicated, this bit. So I've simplified it enormously here. But there may be a situation where we are handing over the call now. So this is not like a fallback scenario. Because in the fallback scenario, the call is never actually placed on the LTE network. Of course, we're redirected before the call takes place. But in this example, what we have is there is a VoLTE call taking place. Okay, so the call is already in place. The bearers are already established through the network. Okay, to wherever the B party happens to be. Now, the call, in fact, in this case, is anchored at the IMS. So, if you like, the point at which the call is controlled from is the IMS. And rather specifically, this thing called the SCCAS, which is the Service Centralization and Continuity Application Server. That's an acronym that always gets me. So Service Continuity, Service Centralization and Continuity Application Server. Okay, so the call is basically controlled from that point. Now, we're in a situation here whereby we're running out of LTE coverage, and the only destination we have is a non-LTE cell, so obviously a 2G, 3G cell, in which case we want to maintain the call, which is currently a packet switching call, but the only way to maintain the telephone call is to convert or hand over the packet switched session to a circuit switch session. So the call is going to continue, okay, on the new part of the network, but this time as a circuit switch call. Now, this is only really possible if you anchor the call session here in the IMS. Now, in order to do this, there's a little bit sort of redirection thing going on here in the access network, in that we get a handover required message being sent to the MME, and what the EUTRAN, the LTE access network, will do will kind of recommend a destination circuit switching network, so a 2G, 3G base station. And the MME will perform this handover trigger via a new interface called the SV interface, and V in this case stands for voice call continuity. What the MSC now has to do, and the MSC requires a bit of modification now, and it has to be an MSC that supports the voice call continuity service. And what the MSC will now do is initiate towards the IMS a session transfer procedure. Okay, so I mean, in times gone past, the MSC has never been connected to the IMS because it really had nothing to do with the packet switching services. But now that the call is anchored in the IMS, we now need a control interface between the MSC and the IMS, just so that the IMS can effectively request the call. Okay, so what the session transfer procedure is really doing is it's saying to the IMS, you have a call whose identity is, and there is a session transfer number associated with this. And what the IMS is then able to do is to start a procedure. Okay, now I need to draw another box in here. There's like an access transfer function. I mean, I'm not worrying too much about the detail in this case, but there is an access transfer function which, if you like, the media connection will be kind of anchored at this point, and at the moment it's going off somewhere, okay, so wherever the B party is. Now this access transfer function, with this sort of session transfer number, there's some sort of reference number in there, we can now control this access transfer function to eliminate this connection. It now goes out through the packet switching domain, okay, and then re-establish the connection via the MSC. Okay, so it's this leg and this leg, so let's call it leg 1 and leg 2, are now connected together, and leg 3 is the one that we can terminate. So there's a whole bunch of new components, new interfaces, new procedures that have to be put into the network in support of this voice call continuity. Now notice as well, there's a little prefix here called SR-VCC. Now this is single radio voice call continuity. Now, so that we don't make the mobiles too complicated, the idea is that there will only ever be a single radio in that mobile. So it can switch very quickly between an LTE mode and a 3G mode and a 2G mode, but it's still only one radio. I mean, there are sort of dual radio scenarios out there. Okay, but now you've got two radios switched on in a mobile. You know, you've got to ask questions about what's the battery life going to be like, and how do you manage a mobile that is maybe connected. It's got one radio pointing at the LTE network, another radio pointing at the 2G, 3G network, and so on. So there might be a bit more sort of complication in terms of that as well. So I mean, okay, I mean this is something for the future, but I suppose if we're being maybe a little bit optimistic here, we could say that the whole SR-VCC thing is still maybe you know, an interim solution, because once you've got 100% LTE coverage and 100% penetration of devices in the market that support LTE and full support of voice over LTE from the operator's network, then there will never be a situation where you need to fall back to a circuit switching network or redirect the call in this handover manner to the circuit switching network. So yeah, maybe an interim solution, but probably one. I mean, the interim, we're probably talking what, 5 years, 10 years maybe. Depends on the operator, depends on the part of the world. Now, if you want something even more complicated, let's just talk about roaming. So my first bullet point, well, it's complicated. Okay, there's a lot of things to sort out here. There are very sort of limited, roaming trials, interconnection trials, and so on that are taking place at the moment. But there's a lot of connection options, and again, I think I might get the document name wrong here, but IR88 seems to ring a bell. Might be the GSMA document that you need to look at for these connection scenarios. So there's tons of different connection options, and those connection options are very dependent on each operator's roadmap. So you know, what components they have currently in the network, what interfaces they support within their own network and across these international boundaries. You know, the S8 is the classic roaming interface where I can connect directly my visited serving gateway directly back to my packet gateway here. But there are lots of options in that I could be an LTE mobile, let's say roaming in a network that doesn't yet support LTE. So how do I connect back to my home network? And such. I mean, there's tons of different scenarios here. And in fact, if you look at this IR88 document, I think you'll find yeah, there's like 10 pages of different connection scenarios. So these things have to be worked through. You know, when you're forming roaming agreements with your partner operators, or perhaps with your IPXs, and all of these different connection type scenarios have to be thought about. Even things like the APN, this access point name, which again, it comes from GPRS, and the access point name basically gives the network some information about how do we connect to a destination network. So the APN could be the IMS, it could be the internet, it could be many different things. So we would need to think about how do I create connections to a home network under roaming scenarios where I'm using the APN as part of my routing information. Again, I'm not really going to say anything else about that because it's kind of complicated, shall we say. And even something like handover whilst roaming. You know, the different domains that I might be moving between. So, you know, 2G, 3G domain towards an LTE domain and so on. And service continuity maybe becomes an issue whilst you're handing over in a roaming scenario. So, yeah, I mean, this slide is really just put into the presentation here. Just to say there's a lot of stuff here to be resolved. Just to say it's complicated and so on. But work is progressing. I mean, obviously 3GPP are working on this along with the GSMA, the GSM Association, and so on. And there's a lot of really great documents out there, and particularly those from the GSM Association. Really good documents, fairly easy to read, I suppose, if you're into that kind of thing. But explaining the scenarios and how we might overcome some of the problems of those scenarios. And one thing I'm not mentioning here is anything really to do with IPXs, but I suppose I could draw like a little bubble in here that sits between the home operator and the visited operator. We might have called that the GRX in the past, but these days we require something called an IPX. And the IPX will offer several different services to these operators. Maybe the most important thing of which is that the IPX now offers, should we say, SIP-aware connectivity services. Okay, because you know we may be exchanging SIP call control messages over international boundaries via the IPX and so on, and that needs to be factored into any services delivered by IPXs. Right, we're nearly there. Another sort of 10 minutes. And we'll come to the Q&A. So what I'm going to give to you now is just some information from the latest Ovum report about VoLTE. So current state of the market, some Ovum recommendations and such like. So of course, many operators, 80 of them in fact in 42 countries, are in the stage of VoLTE planning, trials, deployment. But only 17 are described as being fully launched, and the 17 you can see in this table here. So we've got a couple in the Americas, quite a few in Asia Pacific actually, the South Korean operators, NTT Docomo in Japan, of course, and in Europe, not so many operators. I mean, Vodafone in Romania and Germany, TDC in Denmark, and in the Middle East, we've also got DO providing VoLTE services there. So it's still very early days for this. I mean, you'll see that most of these have come online. South Korea, 2012. A little bit ahead of the game there. But most of them were sort of second half last year. There's a couple that have launched very, very well. In fact, there's Canada Rogers Wireless just this month, in fact. But I think what we're going to see is perhaps in 2015, those 80 operators that are currently conducting trials and so on will go into commercial deployments. But we shouldn't kind of lose sight of the fact that the challenge that faces many of these operators, and it is quite a big technical challenge, is the fact that in order to do voice over LTE, of course, you need LTE coverage, and you also need a device that supports the LTE application, the VoLTE subscriptions, and so on. All of those things need to be kind of put in place. So some recommendations really from Ovum. So I mean, you can. I mean, these are. I think the emphasis here is on the word a recommendation. Okay. These may not apply to every operator in every part of the world. It completely depends on their business case and how sort of well along the roadmap they are towards VoLTE and so on. Okay, but what the Ovum analysts are saying is that operators should focus on offering an enhanced voice experience for customers. Okay, so you could interpret that in many different ways. What do we mean by enhanced voice? Probably like an HD voice, high quality voice. So the type of voice experience that you would have maybe on Viber or Skype when you've got a good internet connection, for example, the voice call quality is typically a lot better than your standard, PSTN or GSM type call. And clearly, it's the logical step. Moving towards VoLTE it's a clear step for the operators. All the operators need to do is to figure out when's the right time to do it. I don't think there, and by all means, correct me when I pull the chat pod back in here, but I don't think there is. VoLTE is going to happen, okay? Whether or not we can derive a clear business case for it, it will become the default, the de facto way of making voice calls. In 10 years' time, it'll just be the way that we do it. But I think that the tricky thing at the moment is evolving that business case, trying to think of a compelling reason to sell the service or to engage the subscribers with VoLTE and so on. I mean, do we even tell the subscribers about VoLTE? Or do we just do it and tell them we've improved the network, and their experience then is better voice call quality, faster call setup time, and perhaps when we start to we start to pull some of those clever services like location information and presence information, and active telephone directories and so on. We begin to kind of introduce slowly to the people these kind of services. So yeah, some sort of clear evaluation of what the business case is for VoLTE, and come up with a launch plan, as I'm saying. Considerable investment, maybe that's a slight understatement. There's a lot of stuff that needs to be done there. And it's not just the VoLTE thing, of course, isn't it? It's the interfaces to support circuit switching fallback. It's the interfaces for the voice call continuity as well. It's the service continuity server. It's a modification to the IMS. And there's a ton of stuff that has to be done. And of course, none of it's going to be particularly cheap. So the business case needs to be pretty clear. I think the timescales need to be realistic as well for the operators. There is an advantage of getting there quickly, though, because there's, cost and complexity of running two separate networks, because you're going to have your MSC, your circuit switching network, and now you've got your voice over IP network, your VoLTE network. It would be great if we could switch off the circuit switching voice sooner rather than later. There's got to be some cost benefits to doing that. But I think, we've got to be realistic about the timescales on that. Operators should evaluate VoLTE commercial models, focus on service differentiation more than price. Now, I think one of the questions I asked at the beginning of this session was, can you charge a premium for VoLTE? And I think most of you answered no. I mean, the question is, how do you make VoLTE different enough or compelling enough that somebody would pay more money for it? And I mean, I'm not even going to try and answer that question, to be honest, because it's, you know, it's down to the operator, the business case, and maybe there is a way of doing this. So enhance customer service experience, okay, maybe provide compelling services. We leave it up to you to figure out what those compelling services might be, differentiated experiences and so on. Yeah, and just carefully evaluate different charging models. Yeah, maybe one thing we've learned from just plain old LTE is that it's very, very difficult to even charge a premium for an enhanced data service, you know, one that's offers faster connections, higher capacity, and so on. A lot of the operators that started off launching VoLTE as a premium data service, what you'll probably find now is that the majority of those have brought their LTE subscription prices down to 3G parity. So there's almost no difference between a 3G subscription and a 4G subscription. It's just now a data subscription. And I think, in fact, Vodafone here in the UK, they announced just a couple of weeks ago that almost that they ceased to differentiate between 3G and 4G data. It's just data now. So almost by default, you're going to get the 4G data plan whenever you buy a data plan from them. So drivers, yeah, user experience. I guess that's the focus, really, isn't it? You know, make it better somehow. South Korea Telecom, I mean, they're saying that VoLTE offers much better voice call quality and connections are 20 times faster than perhaps a 3G network. The other thing as well, I mean, we're talking about this sort of dual transfer mode, so I've got voice and data at the same time. That's got to be a clear benefit, because I'm sure quite a few of you, you'll be speaking on the phone, okay, and you'll be sort of going through your emails and so on. You're in a conference call and you can't remember the date you said you could be available and so on. So you're going through your email and your calendar, and all of that requires that you've got this simultaneous connection, and that's something that will be quite easy to do once you've got the VoLTE network in there. But also it's voice and video, voice and multimedia, whatever we might think multimedia means in this. But you'll see in quite a lot of these bullet points when you review this presentation later, you'll see that compete with OTT offerings. Because many of the compelling services that we might come up with, we could probably point at an OTT provider saying, well, okay, they're doing that already, or they've been doing that for a few years, and it doesn't cost me any extra to get that service from this provider. So I mean, that's the reality of the VoLTE market, I think, for the operators. Okay, and some technical stuff like spectral efficiency gains. If I can switch off my 2G network, I can release that spectrum, and I can put that spectrum back into my LTE network, enhancing the capacity, being more spectrally efficient as a result. Challenges. Well, okay, operators consider interworking and interoperability to be a major challenge. So this is interworking interoperability perhaps with the existing network, so that's your fallback and your voice call continuity services, but it's also interworking with other operators. So a Vodafone subscriber calls an O2 subscriber, for example. I mean, that would be a fairly, shall we say, simple scenario, but nevertheless there has to be some pretty detailed thought in how do we make those connections. Your SIP messages are going from my IMS to your IMS. How are we going to do this? And then of course there's all of the roaming stuff. Those are equally interworking interoperability things that need to be thought about. But there's obviously there's a lot of trials taking place. So China Mobile, Korea Telecom, and so on are undertaking quite a lot of trials at the moment. Yeah, key challenge: VoLTE commercial models not fully defined yet. Yeah, fair enough. I mean, there's 17 operators, I think, worldwide that have launched. They'll be kind of carving new ground as they go to find out how the users react to the service. Whether we can charge a premium, how the users would even use the services. Will they make use of the enhanced services, or will they just use it to make and receive basic phone calls? So we need to know a lot more. We need to do a lot of trials, a lot of analysis and investigation to figure out even what the business model is. It's a progressive strategy. I think there's circuit switching fallback. It's here to stay for quite a while. Okay, if you're building a VoLTE network or an LTE network, you need circuit switching fallback. You can't really go much further with a system without that. Without big session discontinuity becomes an issue if you don't support the circuit switching fallback for the user, and obviously user experience is a key thing for the overall user experience. Single radio single radio voice call continuity, maybe a little bit further down the roadmap, but once you've got the VoLTE network up and running, you're still going to have to be able to support packet switched to circuit switched call handover. And actually, when we get to release 12, I think it is, in 3GPP specifications, the calls can come back the other way. So you could actually do it. You could take a circuit switching call and hand it over to the packet switch network and to the LTE network. But that's in release 12, 13, I think. And for CDMA operators, there you go, simultaneous voice and data. So 2 radios run LTE services and so on. Maybe a little bit complicated, but that's one of the sort of the, should we say, interim solutions, progressive strategies that might be present. And the final slide, voice over Wi-Fi. Maybe one thing that is being considered, in fact, is being used by many operators, is this idea of Wi-Fi offload. Okay, so we build a very expensive LTE network, but we don't want you to use it because it's expensive for us to run. So what we can try and do is to push you off onto a Wi-Fi network where it's available. Now that clearly is for to relieve the network of some congestion, some YouTube videos and such like. But once we've got this kind of Wi-Fi connectivity, well, why not voice over Wi-Fi? I mean, there are some considerations in this. I mean, we've seen Apple launch the iPhone 6, and I think their latest iOS 8 something now supports voice over Wi-Fi. So that capability may well kind of spur the operators into developing their own voice over Wi-Fi services as well. And this is likely something that will have to be sort of embedded as part of what we might consider to be the VoLTE service. Remember that VoLTE, or the IMS cloud, doesn't care what the IP connectivity is, LTE or Wi-Fi, it doesn't care. But there are clearly some connection issues. Can we hand over between the LTE network and the Wi-Fi network? And how do we authenticate the user or bill the user while they're making calls on the Wi-Fi network? Can we do quality of service even through the Wi-Fi network? So if you're connected to hotel Wi-Fi or airport Wi-Fi and you're making voice over LTE, well, if you're making voice over Wi-Fi calls, billing, quality, all of those things are issues that need to be determined. And for the time being, at least, I mean, this will be different even in 6 months, that there's still a limited amount of devices on the market that would even support, voice over Wi-Fi. Maybe something we don't really consider, because I mean, if you're doing, Skype or Viber, whatever, those other OTTs, then they support Wi-Fi. You can make the call over Wi-Fi and so on. But what they lack perhaps is any aspect of mobility. You can't really kind of you can't walk down the street, drive down the street, making calls over making a Skype call over Wi-Fi. That mobility thing is sort of missing. But that's something that maybe it's that might be the edge that the operator has again, depending on their relationship with the provider of the Wi-Fi service. Okay, right. So if you want to know more, come and join us on a training program. The current voice over LTE that we have is a 2-day program, and we kind of cover pretty much the topics we've been through today. But of course, we spend 2 days talking about those things. So on the IMS architecture in detail, we'll look at the VoLTE signaling. We say a lot more about roaming and so on. And we look at how it might perform and so on. So you can see the dates we've got there. So I don't know, do you fancy a visit to Amsterdam, maybe Johannesburg? Nice this time of year. London, Singapore, perhaps a bit later in the year, Dallas. So depending on which part of the world you're in, we try and put these sessions on in convenient locations, shall we say. So contact details are there. So a telephone number, email address, or if you want to know more, if you want to get the full brochure, full course descriptions on, then obviously visit our telecomsacademy.com, and you can download the full brochure and see what our timetable is, not just for the VoLTE training, but for pretty much everything else we do as well. We do a lot of stuff on LTE, so LTE planning, LTE overviews, stuff like that. But visit the website; it will all be there. Okay, so the chat pod is back on the screen now. So we'll maybe give you a few minutes to sort of type questions and so on. I'll try to answer what I can. I'm not sure how many people we have on the session here. We have 78 people standing by, so I may not be able to answer all the questions if you all type all at once, but I'll do my best. If you've got no questions, that's absolutely fine. One thing I also need to do, you may want a copy of this presentation. So there's a PDF of the slides that we've that we've prepared here. So the slides that I've been talking about, you can download that PDF. We've also recorded this session, so I'll be passing that a link to the recording to Paul Waite, our marketing guy, and he will doubtless be in touch with you later with a link to that, so you can review the stuff that we talked about. So yeah, thanks for your comments. I'm kind of reading them as they come up. For recommended reading for GSMA. Okay, I recommend a visit to the GSMA website, because if memory serves me correctly here, you will find an IR document there that talks about voice over Wi-Fi, as well as all the complicated roaming stuff as well. So yeah, GSMA is your friend, I think, in this case. Kong, will OTT let text messaging vanish in the near future? Good question. Probably not for the time being. One thing I would say about the OTT is obviously the messaging is very, it's quick and efficient and very cheap and so on. But if I'm on Skype and you're on WhatsApp, I can't send you a message. That's really what it comes down to. But text messaging, the good old SMS messaging, I can send an SMS message to any one of the 7 billion mobile phones that are out there in the network, and I absolutely know, because it's based on a 20-year-old end-to-end standard, the SMS is absolutely compatible. But the moment OTT, there's so many of them, it's impossible to say compatibility. This is one thing maybe VoLTE will bring back in, because the VoLTE messaging is like SMS. Some of you might remember that that good old word, teleservices. Not a word we really use these days, but that's what VoLTE is. It's a definition of a teleservice. So Mohammed, so how is IoT and integration to the existing network challenge? Ooh, crikey bobs. Not sure I can answer that one, Mohammed. We might need to revisit that. One thing I should probably mention as well is we're going to try and start doing some of these little insight webinars on a more regular basis. So Paul Waite sent out a bit of a survey. I think some of you filled that in. So the things that people are interested in are things like 5G, of course 5G, things like IoT, Internet of Things, and so on. So actually, Mohammed, keep an eye out for Paul's email, because we'll probably be running a session like this on IoT, and maybe I can answer your question then. So good stuff. Thanks for your comments again. So Khalid, how do you foresee convergence service going along? Well, yeah, that's another good question, actually, because one thing I didn't mention in the presentation here was that VoLTE is clearly seen to be a mobile thing. Okay, and IMS maybe we still consider to be a sort of a mobile, mobile technology. But if you look at what ETSI are doing, I mean, they've got these initiatives called TISPAN, okay, and one or two other things. So there's a lot of parallel development between what ETSI are doing for the fixed networks and what 3GPP are doing for the mobile networks. So there's and because VoLTE and IMS is sort of, should we say, connection agnostic, then actually I think there's convergence. VoLTE will work just as well on a fixed landline, given that we have an IP connection and quality of service. So yeah, I think VoLTE might be in a good place to drive that convergence thing forward. And when you see big operators like and I forget who's buying who at the moment. BT bought EE, I think it was, or EE bought BT here in the UK. So you've got a massive fixed network operator now with the biggest mobile operator in the world, and we expect to see them doing good things in terms of convergence. So VoLTE and the IMS thing that sits right at the heart of that may well be a good future, I think, for those guys. So Abiodun. LTE and VoLTE still share the same access. Yeah. Well, yeah, yes and no. Okay, we can say the LTE access network is completely different. The new base stations, new radio interface, and so on. But if we consider VoLTE to be the IMS connection, then so long as you get an IP packet through the network with a reasonable degree of quality, then sure. But the access transmission scheme is for GSM and GPRS probably isn't good enough to support the VoLTE connection. Maybe you could do VoLTE messaging through a GPRS connection, but no, it's quite different. It's quite different. Pluquet, SR-VCC in both directions? Yes. By 3GPP release 12 or 13, I can't remember now. At the moment, it's LTE to circuit switching. Okay, release 12 has it the other way, so circuit switching to packet switch. And if I'm absolutely honest, I've not read that specification yet, so I don't know how it's going to work. An important component of VCC in any case is this sort of service centralization idea and the fact the calls are anchored in the IMS. So what that probably means is that your circuit switching call, or your apparently circuit switching call, will be set up and anchored in the IMS, even though it's been made through an MSC server. So Khalid, how is VoLTE delay performance compared to that of circuit switched? Better. Call setup time, at least according to South Korea Telecom, one or two others, saying call setup time is something like 20 times faster. So it's almost like an instantly connected in there. And the user plane delay performance is comparable, shall we say? Comparable. It depends where the A and the B parties are. If there's any third-party network sitting between the A and the B party, then we perhaps need to readdress that. But within the operator's administrative zone, so A and B party connected to the same network, yeah, certainly definitely comparable. Sim, is IMS available for a distributed scenario, normative core for disaster relief? Ooh, not sure I can answer that one. I'll have to think about that one, Sim. But maybe. So Sim, again, if quality of service job PCRF and the ENOB want it, yeah, because I mean the PCRF has almost got like two inputs. Okay, so if you like, when I'm if I'm just connecting to the internet, okay, the PCRF kind of makes the decision about what the quality will be. Okay, but when I'm making an IMS connection, okay, so I'm setting up a a voice and video call. Really, it's the IMS that talks to the PCRF and say, okay, right, this guy is authorized to have a voice and video connection of this quality, and then the PCRF can manipulate the bearer in the network. Okay, so we're giving control to the IMS, because only the IMS really knows exactly what the person wants to do, what the call session is going to be about, because it can look in the SIP messages, it can pull out the data from the SDP and see exactly what's going on. Okay, so you've got to give the IMS that degree of control, but of course there will be other services where the IMS has no control, and the PCRF has to be in charge in that case. So Ed, is the thought of expanding VoLTE service concepts? Yeah. In fact, I think, as I mentioned before, things like TieSpan and what Etsy are doing, this whole idea of convergence. So there's absolutely no reason why VoLTE couldn't sort of be backwardly compatible. So the only thing stopping us maybe from doing that is, does your 3G network have sufficient quality of service compliance to make it reliable? I mean, that would be the only thing. But if you probably more realistic on an HSPA plus network, which I'm sure that's what you mean. But yeah, quality of service is absolutely key to this. So if you can extend your quality of service out to 3G, then sure, why not? It's a bit of an old standard now, but I think 3GPP did have a standard called Voice over HSPA plus. So that's still there on their servers if you want to go and find that one. Yeah, Sim again. PCRF is pre-programmed for the APN. How is quality of service associated with the IMS? Right. Well, the default bearer, okay, has if you like, a pre-programmed APN. Okay, so it's the MME that initiates the default bearer. Okay, and we would set the default APN to be IMS. And so therefore, when the packet gateway, sorry, I'm doing this without the aid of a diagram here, so you need to use your imagination a little bit. Okay, but the MME initiates the default bearer. Okay, the P gateway will examine the APN to figure out who am I connecting to here. And if that APN is pointing at the IMS, then there is again the relationship between the P gateway and the PCRF. So what the P gateway will do is have a quick chat with the PCRF and say, okay, this guy wants to connect to the IMS. What do we do? So the PCRF will have a default rule for any connections where the APN is IMS. So it'll be right, okay, connect them straight away, instantly. Okay, QCI 5, low delay connection, and so on. So sure, there is a pre-programmed, or if you prefer, a default rule for IMS-based APNs. Mohammed, there's $1 million question there. Do you think VoLTE can compete with OTE, with OTT? In the long run, yes. Okay, but there's a lot of work to do. Okay, because the OTTs have had what, 4 years, 5 years maybe. You know, can't remember when WhatsApp came out. Okay, and Skype's been around for a lot longer on desktops and so on. So there's a lot of work to do to regain the ground, perhaps lost to OTT. So, but yeah, in the long run, So is embedded VoLTE client better or IMS client? Yeah, I've done some reading on that actually. Yeah, embedded VoLTE client seems to be better. Rather than sort of because the IMS client is, should we say, an application that floats around on the phone and has to make use of the operating system APIs and so on, and you know, there'll be some, you know, issues, should we say, in that. So some sort of embedded part of the operating system VoLTE client will be better because you've got more control over the should we say the protocol stack of the device and so on. So altogether better, quicker, faster. You know, or part of the hardware architecture, even of the phone, I think would make it a lot better. And Paul, thanks for your comment. That's great. Estavio, will VoLTE underpin new service innovations, strengthen competitive edge, and provide differentiation? Right, it's a good and complicated question. I think the really quick answer there will be yes, in the long run, right, in the long term. So, yeah, watch this space for the next 5 years. Okay, and let's see what the operators do with it, because VoLTE is, should we say, at the moment is it's an opportunity, shall we say. I'm sorry to use some management language there, but it's an opportunity that the operators have to kind of, you know, I don't know, grasp with both hands and kind of, you know, make a big thing of it. Whether that's just done by stealth or through kind of huge marketing campaign describing, you know, how much we've improved the network and look at these great services, look at these great features, and so on. But yeah, a lot of things have to be in place. I mean, when we get the embedded client in all of the telephones supported by the you know, but the iOS and Android and you know, you know, the Microsoft Nokia you know, Windows platform as well. Yeah, yes, in the long run, I would say. Right, okay. Right, one more question. I think one more question. So Kong, I think you're the winner of the last question. Will call connection delay? Well, it should if, and it's quite a big if you've got full control over the quality of service in the connection. Okay, so remember that QCI 1, okay, where we had a delay budget of 100 milliseconds and a guaranteed bit rate of 32 kilobits per second, or whatever the rate would be. Then yeah, if your transmission network, your transportation system, across the radio interface, through the S1 interface, through the S5 interface, and all of the switches and components, aggregators in the network, if they all absolutely agree on what the quality of service language is, then yes. Okay, but remember, weakest link, okay, you've got one slightly dodgy connection, then the whole thing falls apart. So there's a degree of integration across the entire network that has to be in place for VoLTE to be in place. Right, Sim, okay, I see you've got another question in there, so maybe one more question. If revenue is not a concern for the enterprise network, would you still recommend VoLTE? Ooh, yeah, another good question. Yeah, I still think VoLTE would be a good idea. Okay, if it was a standalone enterprise solution that you were providing and you had no interest at all in providing VoLTE services to anybody else, then okay, you know, an off-the-shelf SIP solution from, you know, any one of the vendors that do it, or use, you know, buy your own hardware, use open source Asterisk, you know, do it nice and cheaply. For an enterprise service, then sure, okay. But I think maybe the operators would have to think a little bit wider than that. Because once you've deployed the VoLTE service, okay, sure, it's more expensive than an off-the-shelf solution. There's a lot more elements to it, but it opens the door for, you know, for roaming, for interoperation, and you can provide them the enterprise solution via the VoLTE network anyway, because in the end, it's just SIP, shall we say. But you can combine that, the billing, you know, the administration process can all be built into the back end of the system rather than having two separate systems again. Remember, the thing that we're trying to do here with VoLTE is to limit the number of systems that we have in the long run. So, you know, one LTE network, one back-end IMS, and then we can build off the back of that, you know, public services, enterprise services, public safety services even, and so on. So, okay, great. Good, and yeah, thanks again for all your kind comments. Hope you enjoyed this. As I said, Paul Waite will be sending a follow-up email containing a link to the recording. I've recorded all the Q's and A's as well, so if you want to review and disagree with me on those, absolutely fine. But thanks for attending. I appreciate your attendance. I'm just going to now leave. I'll just collapse that little box. I'm going to leave this slide up so you can get the contact details and so on from there. In fact, let me just drag this one back in. So thanks very much. I'm going to switch off my microphone now and have a good day.